vast, so large that it escapes their perception. Those who see it will be thought of as insane. Illusion will be created so vast, so large that it escapes their perception. Those who see it will be thought of as insane. Everyone is taught these lies when they go to school, but I won't go back to the ball.
This is Apollo Control at 5 hours 30 minutes. Ground elapsed time.
That view of the Earth for Rev there was something I was looking forward to and was not disappointed.
That's great, Jack.
Could you give us our distance from the Earth?
18,100, Fido says.
Okay, and I suppose we're seeing as 100% full Earth as we'll ever see. Certainly as I've ever seen. Well, it's these kind of views that stick with you forever.
Did you get any pictures of that, Jack?
Oh yeah, we got some pictures earlier. I'm going to get another one here in a minute. I'll tell you, if there ever was a fragile appearing piece of blue in space, it's the Earth right now.
Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball. Everyone is taught these lies when they go to school, but I won't go back to the ball.
Interested in Space has seen this picture. It was released by NASA and has the iconic name, the Blue Marble 2. You can find the picture everywhere, but one of the best places to find it is NASA's own website. This photograph is iconic because NASA says it is one of the most detailed true-color images of the entire Earth to date. To put it in a nutshell, the picture is iconic. Well, amazingly, it turns out a number of internet sleuths have now found compelling new evidence that the image is indeed a fake. Now, let's take a look. At first, the photo seems legit. I mean, it looks like Earth, the Earth that we have always been told we live on. But as the savvy internet sleuths point out, if you take a closer look, things start to take a somewhat sinister turn. Look closely at the repeating cloud pattern. Here we can see clear examples that the photograph has not only been doctored or constructed, but also strong evidence that whoever done the doctoring used repeating photographic templates. That is, they cloned parts of the image and repeated it. That is, the photograph is a construction. This does not happen in nature. Clouds do not repeat in the same pattern like this. The chances of this happening in the same photograph are low. The only way this could happen is if someone has cloned clouds and painted them on. This, of course, could be for a number of reasons. You could argue that NASA simply touched up the photograph for effect, or that it was a problem with the imaging systems that were used. But still the question exists. Why is NASA releasing fake pictures of Earth? If they are going to release a picture of Earth to be used in museums and by educators, as they state for the Blue Marble 2, then should they not release real images of Earth instead, or manipulated or fake images? Since the natural extension of this is, what other images have they doctored? The Moon, Pluto, Mars? Maybe all of them. And if they are faking pictures to such an extent, whether by wanting them to look better, or other reasons, then what real scientific value are they? Isn't science about finding the truth? And is that not hard to do when you are being fed inaccurate, or in this case, completely manufactured data? NASA says these images are to be used by educators, museums, and scientists, which means they are passing off the image as a real picture of Earth when it is not. What do you guys think? Do you think something sinister is going on? Or is there some harmless and less exotic reason?
There are great ideas undiscovered. Breakthroughs available to those who can remove one of truth's protective layers.
Then in 2002, Blue Marble 2.0, NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is. A composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it. There's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be.
While I was looking into curvature math and looking into stuff like this, I came across an interesting word problem, which, ironically enough, absolutely nullifies the entire baller thesis. And it does so using their math. Check this out. All right. This is a website called mathcentral.euregina.ca. I'm not sure if I pronounced that right, but whatever. Anyway, you see the URL here. So they're talking about how can I find the curvature per mile of the Earth's surface, and they give an answer right here. And they say after you do all the long form math, it ends up being 7.98 inches, or like we said, everybody's just kind of rounding it up to 8 inches per mile. All right, but then it says, look at our response to Shirley to see what happens after the first mile. So you click on this, and there's an interesting question posed here at the top. There are two 6-foot men. What would the distance be between them before one could not be seen because of the curvature of the Earth? And this is apparently, this person, Shirley, had a grandson who was stationed in Baghdad, Iraq, who was asking the question. And he goes to explain, it's 8 inches per mile, blah, 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 but it's not, 6 feet is 72 inches. So 8 times 9 would be 72. So you might be thinking, well, it's 9 miles. The dude would have to be 9 miles away for a 6-foot person to be obscured at 8 inches per mile. Well, no, it's not a slant. It's a curve. It's a ball. So you can't just, multiply 8 times the miles. And when they go through all the Pythagorean theorem and blah, 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 you end up with 3 miles as your answer. Okay, so at 3 miles now, and we'll go back to our chart here, assuming your eye level is at the ground, 3 miles, 6 foot is obscured. Now this is what's interesting, and I'll create a little animation here for you to be able to visualize what I'm thinking here. And I'll let you think this through with me. Okay, let's just imagine our world as a beach ball. Alright, the lines of the ball clearly point out what so many in the Ball Earth camp are blatantly ignoring. A ball, by its very nature, demands that its surface immediately begins to curve downward and away from any point on it. So if we imagine Poser James here, I'm using a software called Poser, let's call him PJ for short. If we imagine him standing on the beach ball, the problem becomes immediately apparent. Okay, he's standing on a ball. Immediately the ball is curving downward and away from his feet in all directions. That's what a ball does. And it doesn't matter how big the person is, nor does it matter how big the ball is. But let's go ahead and shrink PJ and enlarge the ball for the sake of example here. Now, notice the lines are still curving downward and away in all directions, even though he's getting smaller and the ball is getting bigger. This never changes with scale. Okay, now let's zoom into tiny PJ on the massive ball here and consider the curvature word problem that was brought up by this individual serving in Iraq. If PJ, who was 6 feet tall and he had a clone, who was also 6 feet tall, right, who walked 1 mile away from him, the ground his clone would be standing on would be 8 inches lower than the ground that he was standing on, right? Again, the curvature math is 8 inches per mile squared. So the first mile, 1 times 1 is 1 times 8 is 8 inches. So the ground from point A to point B is going to be 8 inches below point A. All right, you with me so far? Now, if the clone had a clone who walked another mile away, that clone's ground would be 32 inches below PJ's ground. Why? Because it's 8 inches per mile squared. 2 miles, okay, 2 times 2 is 4 times 8 is 32. So the ground that clone number 2 is standing on is 32, almost 3 feet below the ground that PJ is standing on. And if we had yet another clone who was to walk 1 more mile, his ground would be 72 inches or 6 feet below PJ's. Thus, the top of clone number 3's head would be even with the bottom of PJ's feet. I know for some of you, the gerbil just jumped off the wheel, so let's look at it again. This time we'll check it out from a different angle. Again, PJ's clone walks 1 mile away. The top of his head would be 8 inches lower than PJ's. Another clone walks an additional mile, and the top of his head is then 32 inches below PJ's. The third clone walks 1 more mile, and at just 3 miles away from PJ, the ground clone number 3 is standing on is 6 feet below PJ's. Thus, the top of clone number 3's head is going to be even with the bottom of PJ's feet. Now, I'm not trying to see whether or not the person can see the other person. What I'm trying to show you is the issue of the ground level. The ground level is the issue that I'm focused on with this example. Because if clone number 3's ground is 72 inches below the ground that PJ is standing on, it's going to be physically impossible for PJ to look straight ahead or to the left or the right or behind him and ever expect to see the horizon at his eye level. It cannot be done. I'm going to say it again. If you're just looking straight ahead, there is no way the horizon could ever be at your eye level. When the ground you're standing on is immediately beginning to recede away from you in every direction, you're standing on a point on a ball, supposedly. The ground you're standing on immediately begins to recede away in every direction, 8 inches per mile squared. Now, I understand we're not on a perfect beach ball, but you actually compound the problem if you start using the argument, well, there are, peaks and valleys and hills and mountains and plateaus and canyons and blah, blah, blah. All you're doing is pushing the problem further out. And eventually you, the ball earther who uses this argument, are the one who's in danger of falling off the edge of something. Because you can extend that out only so far, and then you're going to have to correct the terrain back to that 8 inches per mile squared so that you can have your 25,000 mile circumference ball. Or pair if you choose to go by Neil deGrasse Tyson. But for this math to be true, and it has to be in order to maintain a 25,000 mile circumference, no person could ever look straight ahead and expect to see the horizon at his eye level. But still, this is what we have to put up with.
The most important thing to understand is that the horizon is flat. That's right. From our vantage point, even from a high mountain or an airplane, the horizon is flat. Flat earthers, and also many globalists, for lack of a better term, seem to think that the horizon should look curved to us. That's flat wrong. And I think this is the single biggest reason there even is a flat earth community, the biggest source of confusion. You are expecting to see a curve where there is none to be seen. You are looking for the wrong thing. To picture what I mean, look at this orange. If I take a thin slice of it, I get a round disc. The edges of it, where the knife cut through, is a flat circle. That is what you see when you look at the horizon, the edges of a circle. The edges don't curve side to side, they run straight across our view. And since we are always in the center of the circle, they don't curve down.
My first question is, why is this dude wearing fingernail polish? But, I guess everybody's entitled to their thing. But my other observation was, after he said, if I take an orange and slice it off, sorry, you can't do that. If your orange is representing the Earth, you've got to leave its spherical nature intact. You can't slice off the top of the sphere that you're using as your example and then say, that's why everything's flat, because I just sliced off the curve. I don't know. Anyway, let's go back to Captain Fingernail Polish and see what other piece of amazing logic he has for us.
When you can see the horizon in all directions, it is the same distance away in all directions. So when you spin around, it looks exactly like a straight line and comes back around to join itself. Think about that. If it were curved down, it would not come back around and join itself at the same level.
Exactly. If it were curved, it would be dropping off 8 inches per mile squared from every point upon which you are standing. That is inescapable ball earth math. Wow. But, okay, to be fair, I do understand what Captain Fingernail Polish is saying here. This is a typical argument that I've heard lots of times, actually. Ball earthers will claim that just like the blue circle at the top of the beach ball here, that's the visible horizon. So from whatever point you're standing on, and you're looking out toward the horizon, in 360 degrees, that line is going to be the same. It's always going to be right there. But as I'm showing you, that only works if you're looking down. I don't care how big the ball is. I don't care how big you are. I don't care how small you are compared to the ball. If you're standing on the ball, the point at which you are standing, from that point outward, is receding downward at an exponential rate. Downward. Which means you can never look out to this mystical circle out in front of you at eye level. It cannot be. It can't happen. So this whole idea right here, while in principle it sounds good, looks good, but it's a myth. It does not exist in the observable, testable, and repeatable example of reality. According to Pythagorean math, the 25,000 mile circumference ball Eratosthenes invented does not allow for us to ever be able to see the supposed edge of a horizon that presents itself at eye level. Yet whether we're on the ground or flying up to 37,000 feet in an airplane or sending up a weather balloon to over 100,000 feet, there's that totally flat horizon straight ahead at our eye level. Always. That's simply not possible if it's receding downward and away from us at a rate of 8 inches per mile squared, which is what it must do. But once again, in reality, we don't see this. Therefore, this whole idea that's depicted here and that was depicted with the slicing of the orange, that whole idea is a myth. It doesn't exist in reality unless you're looking downward, which I don't know about you, but I don't go around in my everyday life looking at the ground. I stand straight up and I look straight out, and there's the horizon at my eye level. Not possible with Pythagorean math on Eratosthenes' ball. And speaking of myths, people who think ships are disappearing over the curve in less than 10 miles distance, it's got to work both ways. I mean, if we're on a ball, then when the ship is going away from you on the, let's say, the z-axis, going, from you to a point away from you, and it's rolling over the ball in less than 10 miles, then you should have the exact same effect looking left to right on the x-axis. You should be seeing ships rolling up to the top of the ball and rolling down on the lateral x-axis. If it's a ball, they got to be rolling both ways, away from you and side to side. We never see that though. You can go to the beach and do a panoramic shot and put a parallel line over it, and from end to end, and this is a lot more than just 5 miles, there's no perceived curvature here. None. Flat as a pancake. In fact, these are some pictures I took on the beach at Malibu, California. And I went from there way up into the mountains above Pepperdine University and looked out. And easily there's got to be probably close to 100 miles left to right. The distance on the horizon there it's got to be, quite a bit there. Put a parallel line over it, flat. So you can't have it both ways. You can't say ships are rolling over the ball on the z-axis without having the same exact perception on the x-axis. I was thinking about that while we were on Lake Michigan. We were on the east coast of the lake looking toward the west. And so if you're standing on the east coast looking toward the west, and you claim that ships are disappearing in 3, 4, 5, 10 miles, whatever, distance, then people who are standing on the southern coastline would make the same claim. If they're on the south looking toward the north, they would say the same thing. Oh, I see ships disappearing in 3, 4, 5, 6, 7, 8, 9, 10 miles away. So if the person standing on the south coast looking north is claiming that ships are disappearing, and the person standing on the east coast looking west is saying the same thing, then both people have to observe the alleged curvature that the other person is claiming their ships are going over. Therefore, like I said, this whole idea of the eye-level horizon being equal, as depicted here, or as depicted when you slice off a piece of an orange, is a myth. Alright, let's continue.
There's a handy website that will calculate the distance to the horizon for any viewing height, and it also tells you how much of an object will be hidden behind the horizon if it's past the horizon. The site is metabunk.org/curve.
So I went there, and this is the calculator that's there, and you can run all the same calculations that I showed you in the other websites. It works very much the same way. But this is what's interesting to me. Let's look at this graphic right here on the bottom. See, they always got this thing in the middle between the observer and the target, and it's called the bulge. And they'll have you believe that everything you're looking at is on the other side of a big hump, a big bulge. You're always going to have to walk uphill first and then walk downhill to get to wherever you're going. In all of these examples, it's always this way. Okay, they got this target, over here, and the observer over here, and this big bulge in the middle. And that's what all these ballers would have you believe, is that everything you're looking at is on the other side of a big bulge you're going to have to walk or drive or swim or take a boat or fly over to get to. And somebody else has done videos on how big that bulge would be if you're flying from Los Angeles to Hawaii. I mean, it gets quite absurd when you start putting it into these terms. But let me just simplify all of this for you and bring PJ back into the picture. Now, he's standing on top of the ball, right? But I'm going to slide him over to the observation point here. Now, I'm keeping him perpendicular to the ground. Now, do you see the problem? The only way he could be looking toward the top of the bulge is if he's tilting his head down. He'd have to be looking down. He couldn't be standing straight up, looking straight out. The only way he's going to see the curve is if he's looking down. Let's keep PJ looking straight ahead, and I'm going to slide him down so that his eyeball essentially ends up on the ground, looking straight out, and you're going to see the problem here. Look, at ground level, if his eyeball is on the ground and he's looking straight out, the ground is beginning to immediately curve downward. There's no bulge. There's no bulge. Balls, it don't work that way. If you're standing perpendicular on top of it at any point on the ball, but yet every single curvature chart you're going to find is going to show this same kind of nonsense, where they either have the observer or the target at ridiculous angles, or they're forcing the observer to look downward, such as in this example, but there's also plenty of others that depict essentially the same thing. In fact, if you go back to the Channel 57 ABC news report, Skyline Skepticism, the Lake Michigan Mirage, you're
Now we have a lot of this story. Come after this newscast, you can see the time lapse, a short lecture by Dr. Rennie, and how you can calculate how far you can see to the horizon based on your location. Reporting live, I'm Chief